Hey everyone, today is going to be the start of my new PCG series where I'm going to be showing you how to create this procedural building where you can have the walls automatically get filled in. Not only that, but you can actually set up the amount of floors you're going to have. Of course, for now, there's no extra floors, but that will come in later. But you can set up how many floors your entire building has. You can also have this work with different sizes of floor tiles or wall tiles. So for example, if I was to swap out the graph, I could just reuse the same blueprint and just change the wall size. So for example, a little bit higher, and it'll also automatically scale the floor to fit accordingly. So if the walls were 400 units wide, they're not actually. That's why there's a gap now. But you see the floor automatically fills in correctly for it because I have set the floor size of the original piece is 300. So it automatically scales things accordingly. We'll be using a lot of the new tools that are available in 5.3 to make this as simple as possible. So with that, let's get into it. So as always, here we are in a brand new project. And to get started, we're going to go to Edit, Plugins, search Procedural, and turn on Procedural Content Generation Framework, PCG, if you haven't already, and then go ahead and restart your engine. And once it's restarted, go ahead and create a blueprint actor. Let's call it BP_building. And a PCG graph. Let's go ahead and open up the blueprint. So in here, we're going to need a couple of things. Let's start by adding a spline, and this is what's going to dictate our shape. So for this, I'm going to go ahead and delete the last point, and then I'm going to just right-click, go to Spline Generation Panel, and I'm going to generate a square, and I'm going to say, by default, let's have it be like 500 units. And then I'm going to search for close in the detail panel and make it a closed loop, and the original point I'm going to change to linear. There we go. So now we have a closed loop spline. Last thing is to add a PCG graph. So we'll go ahead and add that in. And in here, I'll plug in the PCG building that we just created. Now we have this nice graph. Of course, nothing's here yet, but now we can begin. Open up the new PCG graph you made. And then in here, we're going to get our spline data that we have created. And we're going to sample it with the spline sampler. And in here, we're going to change it on interior. And if I sample it, you can see it is actually still on the edges. It is not on the interior. Now, this is a 5.3 bug. You don't need to do this on 5.2, but in 5.3, you do need to check unbounded. And now it will actually populate inside of it. So for the interior sample size, that's actually the size of our floor tiles, effectively, that we're going to be using. In my case, I know they're 300. And if I was to take this and then extend this out, you can see it is creating the grid 300 points across. So we want to control this. So let's start with making some parameters. I'm going to open up my blueprint. And in the blueprint, I'm going to expose a variable here. And we're going to call it floor size. It is going to be a float. And we're going to expose it. And I'm going to duplicate it and name one of them wall size. Because we're going to need a wall size and a floor size. For both of these values, make sure that you give it a default value that is not 0. So I know that my floor size will be 300 and my wall size will be roughly 300. So I'll just enter 300 for now for both of them. So I'm going to compile and save the blueprint. If you put 0 in here, when you add the values into the PCG graph, it'll pretty much crash because it will be an infinite loop of scaling it by 0. So for this, we're going to use this based on the wall itself. So what I'm going to do is right click and get property for get actor property. And I'm going to plug in our variable in here. So in this case, I'm going to use wall size. So I'm going to copy paste it. So it's going to be named exactly the same. Open this up. We go ahead and plug this into interior sample spacing. So effectively, this value is now controlled by our exposed blueprint. There we are. We have the nice grid here, 300 units across. And if I go in and adjust it in the blueprint, I can make these further and closer apart automatically. So great. So this is working as we want. Now let's go ahead and populate in our floor. To do that, we'll go ahead and first get a static mesh spawner. And I'm going to go ahead and add a mesh entry. And I have gone ahead and download a couple of Megascans assets. So in my case, I'm just going to be using a roof mesh, but it is a flat mesh. As you can see right here, it is a nice flat mesh that we can just use as the floor for the meantime. Now, the one thing you can immediately tell is the pivot point on this mesh, if I was to drag it out, is in the corner. We kind of want it in the center. So for that, what we want to do is offset the location of it. For that, we just go ahead and drag out a transform point, plug that into our static mesh. You just alt click on the graph to remove the extra node. And we want to offset it here. Now, we can plug in actual values in here and offset this, right? We know it's 150, so we can offset things. Yeah, it'd be negative 150, 150, and now you can see it is in the right location. But this is hard coded, and we don't want it to be hard coded. So now with 5.3, we do have some nice integration between the blueprints and the PCG, which is where we're going to be using. So if you click here on Edit the Graph Settings, you scroll down, you have instance parameters. So we're going to be using these. So I'm going to create 2 parameters. Both of these are going to be vector parameters. And you can just left click on them and then change the variable to vector. And then same thing, left click, and you can rename it. One of them I'm going to call floor offset. And the second one I'm going to call floor scale. And then in the blueprint, we can go into our construction script and actually reference all this information. So for that, I just drag in the PCG and get graph instance. And from here, I can now access all of those parameters. So what we're going to do is set vector parameter. Now, we're going to need 2 of these. So I'm just going to immediately move this up and just duplicate this. Plug this into the second graph. So to make it easy for myself, I'm just going to copy the name that I've put into one and copy the name I've put into the other. So that way they're named exactly the same. So for the floor offset, we know based on our values here, we've put it into -half and half of our wall size. So what we're going to do is drag this out. If you'll control, it automatically gets a get node. So we get our wall size. We're going to divide this by 2. And we also need to then get a negative of it. So I'm going to multiply it by -1. And then we're going to right click on the values for the vectors and split them. So we get the X, Y, Z separated out. So now we can plug this in the same way we have it here, right? So it's negative for the X, positive for the Y. So we're going to put negative for the X, positive for the Y, for the floor offset. Now, for the scale, that is a little bit different. The scale we want to change if the walls are, let's say, 330 units wide and the floor is only 300 units wide. We want to scale this by the proportion it is. For this one, what we're going to do is take our floor size and take our wall size, and we're going to divide our wall size by our floor size. Let's grab a divide node, plug this in, and actually we can recombine this one and just plug this in directly, and it'll just add us a conversion node. So now, whatever we have the wall size is, if it is too big compared to the floor, then it will automatically scale it accordingly. Nothing has changed, right? We are not accessing these values yet. So for that, we'll go ahead and come here, and you can just right click and get floor offset and get floor scale. So the offset will go into offset min and max. So we have exactly the same offset for both. And the floor scale is going to go into scale, min and max. And we can stop sampling the spline sampler at this point. And you can see it's exactly in the same location. But now, if I go into our blueprint graph, right, and I change the wall size to say 400, you can see it has now scaled the points where it is fitting for each situation. Even though it knows that the actual floor is 300, it is now properly scaling things accordingly. Perfect. So this is our simple floor. Now the floor is very easy. The complicated part, of course, is the walls. So let's get to that. So to get the walls, we're basically going to need to create the walls on all 4 sides. So the easiest way to do that is to take the original points that we have and basically make points on every single side and then remove the ones we don't need. So to do that, we're going to get a transform node, and we're going to set the offset on the rotation to be -90. And then we're going to duplicate it to be positive for both. And we're going to plug this into both of them. And what I'm going to do is just use a reroute node here. I'm going to do the same thing, but instead of -90 and 90, we're going to change it to be 0 and 180. So these are the rotations of the walls. But of course, if I sample this, it's still all stacked. So we need to also offset these. Now, again, just like we did up here, let's go ahead and create some procedural parameters that we can go ahead and offset these depending on the size of our wall. Let's go ahead and go into graph settings, and I'll make 4 variables here. All of them will be vectors. and we'll rename them all to be wall offset 1, 2, 3, and 4. So now we have those. I can go ahead and plug those in immediately. So if I expose these, we can search for get wall offset 4 and immediately plug this into offset min and max and do the same thing for the other 3. So there we go. We plug this in, but of course it's still all stacked because we have not actually put values on these. So let's go ahead and set the values on this guy. So I'm just going to duplicate the one we have split up. I'm going to duplicate it 4 times and plug in our graph instance into the graph instance slot. Okay, there we are. So for this, it's quite simple. We're going to get our wall size, which was the one we are controlling for the walls, of course. And we're going to divide it by 2 because we need to offset it by half. I'm going to grab rename these to, instead of floor offset, will be wall offset 1, 2, 3, and 4. So the first one is going to be wall offset divide by 2, plug into X. And the second one is going to be negative. So we'll go and multiply it by -1 and plug that into X. Now, the second 3 and 4 are going to be the same thing, but they're plugged into Y. Just plug in the 2 values, and I can just drag this out, make it nice and clean. And you can see already we're getting the points around it. The reason you don't see the middle one is because right now we're sampling these guys, we're not sampling the sampler. So if I sample the sampler, of course, we see the original. But right now, we actually have each floor has these stacked. And because they're stacked, we can actually use themselves as a way of clearing each other out. So by using a difference node for each one of these, we can say if it is basically stacked, then remove it. So if this one and this one stack, remove it. And if the opposite is true, also remove it. And I'll just sample these guys instead of these so you can see what we're doing here. So again, if this one stacks with this guy, or the opposite, this one stacks with this guy. And you can see we have now removed anything here that has been stacked. Fantastic. So now we're just left with the points on the exterior. From here, I'm going to go ahead and merge this all into a single node using the merge node. So that way, all of these are not actually individual graphs. They're considered to be one graph. So I'll plug all of these into the 2-point node as going to a merge node. So this is considered to be one graph. And you can see that if we go in here and change the wall size to 350, 250, the points automatically get spread out accordingly as they would need to be. So from here, you can go ahead and get a static mesh spawner, grab yourself one of the models you have for the walls/windows, and I'll go ahead and plug in the static mesh spawner. And you can see it has placed them in the right orientation, but they're kind of offset, right? Because again, the pivot point of this isn't in the correct location relative to how we want it. So again, we're going to need to offset these. So once again, I'm going to grab ourselves a transform point, plug this in between, and we're going to go ahead and add ourselves another parameter. And in here, I'm going to call it wall offset pivot, make it a vector, and then we're going to get wall offset pivot, and we're plugging this in to our offset min and offset max. And of course, with that, we need to go ahead and make another set vector parameter node in our construction script. So for this guy, what we're going to do is offset it by -0.5. So that way it's all scooched over. So I'm going to grab our wall size and divide it, divide and multiply -1. So I'm just going to take all of this and plug this in and plug this into X. And if I compile it, you can see it is now offset. Now, it is still not considering the thickness of the wall itself. So what we're going to do is add a variable here that's going to be exposed. I'm going to call it wall thickness and make it a float and expose that. And I'm going to make it a default of something like 40 because I know that's about how much is needed for this guy. I'm going to take this and I'm going to plug it into Y. And you can see immediately it has moved over. So now I can make the walls a bit thicker and it kind of pushes them out. So in my case, I know the wall size is actually around 310. And so now it has lined up pretty well. So already we have a building that we can now play around with in different shapes. That is a single story. Now, of course, we want something a little more complex than this, but already the basic of it is there. Now comes the part where we need to increase the amount of floors it has. And that's where things get a lot more complicated. But don't worry, I'll guide you through it. So to control the height of the building, there's many ways to do this. I'll share the way I've decided to do it, and that is creating a spline and then working with offsets from there. So what we're going to do is get actor data on itself. And in the actor data, what we can do is get a single point. So if I was to sample this, you can see it's a single point, which is great, which is kind of what we want. So from there, I'm just going to transform points. So there it is. There's a single point. And what we're going to do is transform the point and effectively have another copy of it above, however high up we need, right? So let's say it's 300 units up. Right? That's the next floor, because if our walls were 300 units, that's where we'd want to start the next one. Now, you may wonder, why do we need this transform points here? For some reason, I noticed that if I was to not have this transform points that we're going to be bringing into a merge node later down here, for some reason, this setup wasn't working, but having it go through the transform points first does. Not super sure why, but this is the simple solution. So we want to procedurally control how high the entire building is actually going to be. And for that, we're going to grab ourselves a new parameter. Yay! I love these parameters. 5.3 has really opened up things so much. As always, we're grabbing vectors. And the reason we're grabbing vectors is because for all of these, it's pretty much vectors, because it's working in 3 axes. I'll go ahead and rename this to building height. And I'm going to get building height and plug this into our offset min, offset max. Now, we aren't actually using that yet, so let's go ahead and plug in another vector parameter into the graph. So our building height is actually quite simple. So we need to get a amount of floors that we're going to be using for the building. So I'm going to call a new variable here, floors, and we're going to make it an int, and we're going to expose it. So depending on how many floors we have, that is how high we want this to go. So we're going to grab our wall size, and we're going to multiply it by our floors. But we can't go directly to multiply it by our floors, because if we have one floor, it will create a point on the base and at the top. So for example, if I plug this in directly and then plug this into Z, and then of course set the value to 1 by default. And actually, let's go ahead and on floors, make the slider range never go below 1, so that way you can't put 0 floors. You can see when it creates the points, it creates one at the start and at the end. And that is why first we need to subtract 1. So now if I set this to 2, you can see it is adding effectively whatever our wall height is, it is putting that last point wherever it needs to be based on that. Perfect. And from here, we're going to create a spline based on these 2 points. Now that's a reason why we have this merge node. These points need to be merged as one effectively graph. And then from here, you can say create spline. If I sample it, you can see we now have a spline here. So if it's a spline, we can sample the spline. Instead of subdivision, we're going to go by distance. And the distance, of course, needs to be whatever our distance is of the actual wall height, right? So if I set 300, we get a point every 300. Now, it is visually kind of odd, so I'm just going to change instead of extents, I'm going to set it to absolute. Distance increment, we can grab from our wall size. I'm going to duplicate this over, and I'm going to plug it into distance increment. And of course, as I mentioned before, you need to click unbounded in 5.3, or otherwise you do not see the actual setup. So now if I have 1, you see 1 point, 2, and if I zoom out here and I say 3, 4, 5, you can see it is now actually adding all these points as I need to. So great. So now we have kind of a setup for floors. So let's go ahead and just play around with, let's say, 3 floors by default. So now what we can do is copy the points from one to the other. So what we're going to do is I'm going to scooch this over. And from these transform points, I'm going to grab a copy points. And what we're going to do is copy from these to these, source being the points we just made, target being the points around. You can plug this in. And you could see that it has placed buildings, but, well, this is odd. Well, it's moving them around. It is offset in a real weird way. If I was to zero out this position, it is actually pretty much correct locations. It is flipped right now, which we still need to adjust, of course, but it is in the correct location. But as soon as I move it, it is offsetting them extra. I am not 100% sure as to why it is doing this. I will be honest. Haven't figured it out. If you do know why it is offsetting it on top of the location of the actual blueprint, leave it down in the comments below. But I do have a workaround that does fix this. Because we now have access to the blueprint information, what we can do is add a transform point here, right in between these two guys. And we need to get ourselves another parameter. I'll go ahead and make another vector, and we'll name it floor copy offset. In the blueprint, go ahead and make another parameter. Okay, and so for this guy, we need to get the actor location, which gets us the location of the actual blueprint graph. And then I'm going to split the spin so we get the values as they are. The y is going to go into y. The x is going to multiply by -1 and then is going to go into the z. And the z is also going to multiply by -1, but it's going to go into the x. And then we're going to go get floor copy offset. And then we're going to plug this into offset min and max. You can see it has now gone ahead and placed them exactly where they need to be. So if I move this around, it sticks, right? Fantastic. But of course, we also still need to flip this. From here, we're going to go ahead and hard code these values in at 180 on X for rotation, which does flip it. You can see it has now been flipped, and 90 on the Y. And you can see it has now lined up. Our wall size seems to be a little bit off. So let's take a look. It seems like the wall height of these isn't square. These are not square values. So in our case, there's a gap in between. For now, what we're going to do is, instead of using wall size in this vertical section, I'm going to go ahead and detach this, and I'm just going to hard code this at 300. I'll keep this here, and I'll put a comment in for myself. In my case, the wall I'm using is not square. It is exactly 300 units tall instead of what it is. So now it is great. But now, if I go to 2, 3, it is all working. But if I go to 1, things break. Things break quite a bit. Ooh. So we can use a lot more new fun nodes to fix this. So effectively, if we're not using multiple floors, we don't need to do all of this. This whole section is not needed. So what we can do is use a branch node. And effectively what it does is if the bool you provided is true, it will go to A, otherwise it'll go to B. So what we're going to do is plug in our transform points into here. If it is true, it is going to go to A. And if it's false, it is going to go to the static mesh spawner. It is going to bypass this. It is not quite a true or false. There's a bool that says output to B. Technically not just true or false, but basically true for B, false for A. Let's go ahead and go into our graph settings, add ourselves a bool this time, and I'm going to call it single floor. We're going to get single floor, and that is what's going to plug into output to B. So depending on this bool, we will output to B. So from here, let's go ahead and set bool parameter. And the way we're going to do this is if floors is equal to 1. If the amount of floors is 1, go ahead and do B. And just like that, it has all been placed back in place, and I can go in here and now increase it. So in our graph, if it is multiple floors, it is going to go ahead and use this spline that we create. But if it's not going to be multiple floors, there's no reason for it to do all of that. It is instead just going to go ahead and spawn it. And so just like that, we now have a multi-floor setup where we can change the amount of floors here. Now, of course, none of these have the actual floor level in here. And in my case, the mesh that I'm using for the walls is actually not designed to be seen from the inside. As you can see, it has all the back faces, but this is just a simple Megascans asset that I grabbed. And we can change the wall size a little bit more. If we want to get that corner kind of not overlapping, set it up at 350, and the floor will automatically scale itself to fit accordingly, as you can see. But there you go. That is how you get a pretty basic building setup with some kind of nice controls. And of course, down the line, we're going to be setting up the floors. We're going to be setting up the ceiling, making variations, making doors. If there's stuff you want to see us do for this building, please let me know in the comments below. I'm open to all suggestions of things you'd want to see and how to customize this building. So with that, thank you guys so much for watching. I hope you enjoyed it. If you liked it, hit the like button, subscribe if you haven't, and I'll see you guys next time. Take care. Bye.